All right, this is the algebra review for the chapter, I guess this is chapter 10, and the first one's on quadratic equations, and the other one's on solving formulas. So I want to go through this because this is definitely something we want to keep our factoring skills up while we're in geometry. So if you start off with number 1, x squared plus 3x minus 28 is equal to 0. So we always want to try to factor first because it's always so much quicker, and most people enjoy factoring a little more. And if you remember, one thing you can do when you're factoring is you can say, I'm trying to multiply, since I've got 3 terms here, I'm trying to multiply to get the number on the end, the constant, negative 28. And at the same time, I'm trying to find the same 2 numbers that multiply to give me negative 28 need to add in the middle to get a positive 3. Now the reason this one is easy is if you look up front, there's not a number in front of here except for the invisible 1. Things like this are a lot easier usually to factor. So we're hoping that we can factor this, and so I'm going to go ahead and draw these, and I'm going to say, okay, let's see if it's going to work out. To get the x squared, we put the x and the x there. And if you think about it, couldn't I say 7 times 4 is 28, and 7 times 4 have a difference of 3, so if it was 7 minus 4, it would give me a 3, and 7 times negative 4 would give me a negative 28. So those are the numbers I'm going to use. Since it's a positive 7, I'll put a plus 7 here, and since it's a negative 4, I'm going to put a minus 4 here, and this actually factors. If you remember, what do I do to solve once I've factored something? I have to set each factor equal to 0. And the reason that works is if I have a 0 on the right-hand side, and any time I solve a quadratic equation, I pretty much want to do that. If I have a 0 on the other side, I can say, well, there's 2 factors or 2 things, 2 parentheses, multiplied over here to give me 0. So that means whatever is in the parentheses, it must be equal, one of them at least has to be equal to 0. As a matter of fact, there's 2 options that could be equal to 0. So I take what's inside of each parentheses and I set it equal to 0. What would cause that to turn into 0? Oh, if I subtract 7 from each side to solve for my x, if I were to plug in a negative 7, that whole thing would turn into 0. So there's one of my answers. But there's another factor, so there's another answer. I might also get an answer of, if I solve this little equation that I made from taking this second factor and setting it equal to 0, if I subtract 4 from each side, I'd get x is negative 4. Okay? So those are my answers there if I solve. So that was then maybe using the quadratic formula. Now some people don't like to factor things that look like this. One of the ways that I was taught to do it, there's 2 ways to do this, and one way is just to say what multiplies to give me 5x squared here. Well, it would have to be 5x and x. There's no other way. So this one's a little less problematic maybe than some that we could look at. But then what do I multiply to get negative 1? Well, it's going to have to be 1 and 1, and one of them is going to have to be negative. So what I do is I try to say, okay, remember if I were to multiply this out, I'd want to get back 5x squared minus 4x minus 1. And the middle term always comes from these 2 inside terms and these 2 outside terms. If you ever have heard the thing FOIL, the inside and the outside terms here usually add up to give you the middle term. Okay, so is there a way to get 1x here and 5x here to add up to negative 4? Well, if I made it a minus 5x, which would mean I need the minus sign right here because this 5x times negative 1 would give me a minus 5x. And then I need a plus 1x, which would come from right there, to add up to negative 4x. I could factor this way and solve it. Let me show you another way to do this that some people like. When there is a number out front, like there is here, another way you can solve this is to use that idea of that little organizer box. But instead of just putting the number on the end here, you put the number out front. And I don't know if you remember this or not, but on quadratics we could label them ax squared plus bx plus c. I can multiply the a and the c, the number out front times the number on the end. If I multiply 5, which is the number out front, times -1, the number on the end, 5 times -1 will give me -5. And then I can say, okay, I want it to multiply to give me -5, but at the same time, I need the two numbers to add up to the -4 in the middle. I'll just write it right here. What numbers would work? Well, I could say that would be -5 times 1 would work. So here's what you do with this second method. Now, this is an entirely different method, okay? The one up front is just called guess and check. That's what typically people call that, guess and check, okay? Down here, this method is called splitting the middle term. Splitting middle term, okay? And the reason it's called that is because what I just did is I figured out how to split my middle term with these two numbers I found. I'm going to go back to the equation. I'm going to write my x squared term like I normally would, but instead of writing -4x, isn't -5x plus 1x -4x? So I'm going to write it like this, -5x plus 1x. I'm going to take those two numbers and put them in front of the x. And then I'm just going to copy down my -1 from the end of the problem. Now, if you're going to do it this way, this comes from doing something called factoring by grouping. When you have 4 terms, you can factor by grouping. And what you do is you look at the first 2 terms together and you say, what would divide out of both terms? Well, a 5x would divide out of both terms. That's my GCF of just those 2 terms. And so what I do now is I need my leftovers in parentheses. Well, if I had 5x squared and I divided out 5x, I would just have an x left. But then there was a subtraction sign, so I'll copy it down. And I had 5x, but I divided all the 5x out. So 5x divided by 5x would just leave me with a 1, which is kind of almost like my placeholder there. Okay, so now I'm going to go look. I'm going to write my plus sign down, and I'm going to go look at these 2 terms. Okay, I have, let me get it up here, I had a 1x minus 1. Well, there's not really a GCF unless you just want to say 1 is the greatest common factor here. But then that's just still x minus 1, isn't it? Equals 0. Do you notice something? Do you notice that I have the same thing here and the same thing here? Since I have the same thing here, it is a GCF, a kind of a new GCF, of the 2 new terms I created. Here's one term, here's another term, because when you have a bunch of stuff multiplied together, they create one term, or they're considered one term when they're written like this. So I can take this x minus 1 that's in both of these out, and then I can write my leftovers down. It's like my new GCF, and what's left over out of this first term here, I'll circle it in red. If I take the x minus 1 out, what's left? Well, 5x. I'm writing my leftovers down again, right? And then if I come over to the second term and I take the x minus 1 out, what's left? Well, there was a plus sign that was kind of between them, and then I wrote the 1 there, thank goodness, because that's going to help me factor it. Now I want you to look at the result of this. This is my answer here for the factoring. Don't I have the same thing here? It's just that they're written in a different order, and that's okay. So I have x minus 1 and 5x plus 1. So either way, I've got to factor it, okay? If I want to solve it, 5x minus 1 times x minus 1, is that right? Or it was 5x plus 1 times x minus 1, just having trouble remembering, is equal to 0. So if I want to solve these, I take each factor. So the first one is 5x plus 1. And I set each factor equal to 0 because I remember that if I have 2 things multiplied together that equal this 0, one of these things has to be equal to 0. It could be the first parentheses factor, or it might be the one that's in the second parentheses. So I have 2 little equations to solve, and I'll get 2 answers. And I expected to get 2 answers because the square in the problem tells me that there's either 2, 1, or 0 answers. It's 2 or less, basically. All right, so if I want to solve this, I could subtract 1 from each side. I get 5x equal -1, and if I want to solve for x, I could divide both sides by 5. That would give me x equal -1/5. That's one of my answers. Over here, if I want to solve the second equation, to get the x by itself, I'll add 1 to each side because it was x minus 1. Those would cancel out. I always do the opposite, don't I? X equal 1. That's my second answer.